Hello students, today we will be going over H1.4, adding, and the title says, and subtracting vectors on the coordinate plane. However, today we are only going to focus on the adding of vectors on the coordinate plane. The objective is I can add and subtract vectors and calculate the magnitude of the resultant. Vocabulary, resultant is the sum of two vectors, okay? We might have a little quiz on vocabulary because sometimes students don't learn the vocabulary and it's important to know the vocabulary. So we're going to review a little bit of the vocabulary right here. So if you see this, what does that mean? It's the magnitude of a vector. Okay, so this particular thing is the magnitude of vector v. And remember, the magnitude is the length of a vector. Okay. Vector naming can be a little letter of the alphabet and with a half arrow, or it could be two capital letters with a little half arrow, or italicized or bold V with a full arrow or even a half arrow. So either one of those. Now, a vector has an initial point and a terminal point. The initial point is called the tail and the terminal point is called the head. So this is vector AB, okay? We're going to get right into method one of adding vectors. So the first method I'm going to teach you is the tip to tail. And in the packet, it says a geometric method for adding two vectors is shown in the figure below. So we have a U here and a V here. So if we add U plus V, when we're using tip to tail, see right here is the head right here. Here's the tail. We're going to take this tip and we're going to put this tail at this tip so we can put them right together. So U plus V, and that's not very straight, but that's okay. And then this will be V. And so our resultant vector goes from U to V. And I'm going to try and draw this, but the angle is pretty awkward. So this is U plus V. And that's how you draw it on the graph when you use a tip to tail method. Okay, so that's one method of adding the two vectors. Now, on your form, it shows U plus V. It gives you this example, and I want to make sure you can see that example pretty good. They actually show the U in component form and V in component form. Now, because they can do that, and because both of them start at the origin, you can simply add the numbers. 5 and 6 gives you 11, and 4 plus -9 is -5. Now, to find the magnitude of that, they didn't show their work here, shame on them, but they should be doing a squared plus b squared is c squared. And if you want to go over that in class, we can, but right now I'm going to move on to method 2. Method 2. Parallelogram rule, tail to tail. This is when they have the same initial point, okay? So adding from the origin is easy, but adding from other initial points is more difficult, and I'll give you a couple of examples of those. Right here, they're just saying, here's U, here's V, and so when they start at the same point here, you can take this and pretend it's moved over here, and you go out to here. You can take this and pretend it's there and moved out to there. So you form this parallelogram, and then U plus V will be from the beginning all the way to the end there. So this would be U plus V, okay? So if you're adding from the origin, say V was, let's see. Oh, well, I'll do an example. Well, let's see if it was 6, 4, that was V. And if we said U was 7, -1, then you could simply add 7 plus 6, and the resultant vector would be 13, comma 3. Okay, so I simply add the x's and then add the y's. Okay, but that becomes very much more challenging when it's not started at the origin. Okay, so now we are going to go on to the next page, page H14, number 3, A plus B. So first I want to see what my component form of A is. Now, it is not going to be -3, -5. That would be just on the graph. For A right here, it's how far over and how far down, okay? So if it's going to the right, it's going to be positive. So A is 3, and then it goes down, so it's going to be a negative. And how much does it go down? 4. So again, it's not the point on the graph, it's how far right or left, and then how far up or down. So our B is going to be over here, we go right 5. Let's see. And up 5. Okay, so if we can get our component form right, it makes this much, much easier. Okay. So we're going to use the parallelogram rule where we say, okay, they both start at the same spot. So this one, I can draw a little dotted line there, this a little dotted line there, and then I know my resultant vector is this, and that's going to be A plus B. Okay. If I have these numbers here, it makes this so much easier. So we say vector A plus vector B, 3 plus 5, 8. And then -4 plus 5 is 1. So there's our component form for the resultant vector of vector A plus vector B. Next, we want to find out what the magnitude or the length of A plus B is. So we will say that right here's our resultant vector, and we're going to say that this, we're going to call this C squared. And we're going to say that's A, so 8 squared plus 1 squared. So C squared equals 64 plus 1. And that is 65. And again, that's C squared. So I have to take the square root of both sides. So when I take the square root of both sides, C is approximately equal to 8.06. Let's round to the nearest hundredth now. And there you have it for number 3. Okay, that was so much fun. Let's do number 4. Okay, S plus T. All right, so we can't just say S is 7 -4 because that would be incorrect. So we have to say, where does it start and where does it end up? Okay, so we're going left, so our first number has to be a negative. So, and how you just count how many over. S goes how many over left? And that is 7. And then we count, oh, it's going up, so it's positive 4. So again, you cannot just go by the coordinate plane. You have to count how many left or right and how many up or down. T, it's going to be right, so the first number is going to be positive because it starts here and goes there. T is going to be right 6. And again, if you wanted to draw your little triangle there, you're going to say right 6. And then how many up? Count them. 8. So T is nice because it starts right there at the origin. So you could just go ahead, oh, it's 6, 8 over there, and you're good. Okay. So then the resultant vector And again, we can do tip to tail. See how it's tip to tail. This tip, and it's this tail of T, the tip of S. So we can start from here, and we just draw it straight up to T. Okay. Now, S plus T, we have our component forms down, so we can go -7 plus 6 is -1. And then 8 plus 4 is 12. Okay. And are you able to see that okay? Oh, sorry about that. So S plus T over here, -7, again, is -1, 12. Okay, now we're finding the magnitude, and I'm going to say S plus T is going to be C squared. Now we're going to put our A squared is the component form, the X value, component form Y value. So we say C squared equals 1 plus 12 times 12, 144. Okay, then I say C squared equals 145. And then we take the square root of each side. Don't forget the last step. So C equals, according to my calculator, 12 point something. And you can pause the video where you need to. So anyway, you can do the rest of this, students. You rock.